Welcome to today's fascinating exploration into the heart of the atom. You might think of the atom as a tiny solar system with electrons orbiting around a nucleus like planets around the sun. But hold on to your hats, because today we're diving into a mind-bending revelation. The atom is not the way you think it is. Picture the atom in your mind. You may envision electrons whizzing around the nucleus in neat circular orbits. Much like planets orbiting the sun, it's a comforting image, one that's been ingrained in our minds since high school science classes. But here's the kicker, it's not quite accurate. Enter the electron cloud model. Instead of fixed paths, electrons actually occupy regions of space known as electron clouds. Think of these clouds as fuzzy three-dimensional probability zones where electrons are likely to be found. We don't know its exact position and where it goes next. It's a far cry from the tidy orbits we once imagined. So why the switcheroo? Well, it all comes down to uncertainty. You see, in the microscopic world of quantum mechanics, particles like electrons don't behave like billiard balls following predictable paths. Instead, they are governed by probability waves, which describe the likelihood of finding them in any given location. This brings us to the famous Heisenberg's uncertainty principle, which states that we can't simultaneously know both the exact position and the exact momentum of a particle with absolute certainty. If you want to reduce the position uncertainty, you will get a bigger momentum uncertainty. If you want to know the momentum better, you will get a bigger position uncertainty. That's the Heisenberg's uncertainty principle, first formulated by German physicist Werner Heisenberg back in 1927.